Hello friends, welcome back to the video lecture series of control system. Today we will start with signal flow graphs. So outline, introduction to the signal flow graphs. In that we will see definition, terminologies and some examples. Then Mason's gain formula along with few examples. Then signal flow graphs from block diagram and design examples. Introduction. Alternative method to block diagram representation developed by Samuel Jefferson Mason. So here block diagram reduction technique already we studied, and we understand that to find transfer function of given block diagram system, it takes so much time and bit complicated method. So in block diagram reduction, step by step we have to do all those activities, simplifications. So it takes so much time. It's a rigorous method. So to avoid that complexity, this person Samuel Mason's introduced Mason's gain formula. So flow graph gain formula, also called Mason's gain formula. A signal flow graph consists of a network in which nodes are connected by directed branch. We will see while looking at example what they are trying to explain us. So now we will move on fundamentals of signal flow graphs. Consider a simple equation below, that is y is equal to x, and we have to draw its signal flow graph. So here x and y, these are two variables, and a is the coefficient, or we can say gain. So we first draw x node and y node. Y is the output, so we just join these two nodes and put arrow from x to y. So x is the input and y is the output, but y is equal to a into x, so we just multiply a with x, so it gives y is equal to x. So this is simple graphical representation or signal flow graph of the given equation. So here few properties are there. Every variable in a signal flow graph is designed by a node. So here there are two variables y and x, so we put two nodes. So as many variables, as many nodes must be present in the signal flow graph. Every transmission function in a signal flow graph is designed by a branch. So this branch, between two nodes there must be some branch present if there is a relation is given in the equation. So here y is equal to x means y, node y is depend on x. So there is a relation between y and x, so that represented by this branch. Branch are always unidirection. The arrow in the branch denotes direction of signal flow. So this is from x to the y is the direction. Signal flow graph models. Now we will look at these two simple expressions, and we have to draw signal flow graph for this equation. So here variables are y1, y2, r1, r2. So first of all we put four nodes. So this is r1, r2, this is y1, y2. So y1 of s is equal to g11 of s into r1 of s. So one signal is coming from r1 of s, whose coefficient or gain is g11 of s. So arrow is pointing from r1 to y1 along with gain of g11 of s. Then plus G12 of S into R2 of S, means second is signal coming from R2 of S with gain of G12 of S. So arrow is pointing from R2 to Y1. Then next equation is Y2 of S is equal to G21 of S into R1 of S. So Y2 of S is one signal is coming from R1 of S along with the gain of G21 of S, and second signal is coming from R2 of S whose gain is G22 of S. So this is the simple representation. First step is we have to represent number of variables is equal to number of nodes. Then each whatever be the relation is given, we have to show the branches, its direction and multiplying gain. So same way, this is one more expression. Here R1 and R2 are inputs and X1 and X2 are output. So X1, X2, R1, R2, these are four nodes. So this is R1 and R2 and this is X1 and X2. So X1 is what? A11 X1. So this is A11 X, okay, A11 X1. So this is a regenerative loop. In this loop starts from X1 and it ends at X1 only. Then A1 to X2. So input from X2 with the gain of A12 plus R1. So there is a coefficient of 1. So gain is 1 and it coming from R1. So direction is from R1 to X1. So X1 expression is completed. Now for X2, A21 X1. From X1 it coming to the X2 with the gain of A21 plus A2 to X2. So it starts from X2 only and ends at X2 only with gain of A22 plus R2. So it starts from R2 and ends at X2. So direction is given and there is a gain of unity. So this is a simple way we can represent signal flow graphs. So this is one more example. Here four outputs are given. So sorry, X0 to X4. So totally 5 nodes we have to consider, and these 4 expressions are given. Accordingly we can easily draw this graph. We just check this graph whether it is correct or not. So X1 is what? A into X0. So this is X0. X1 into X1 is A into X0. This is fine. Plus B X1. Where is the B? This is X1. So B into X1 regenerative. Then C X2. So X2 is here. So multiplied with C. So C X2. So first equation is absolutely right. X2 is dx1 plus ex3. So this is dx1 plus ex3. Then x3 is fx0. So from x0 multiplied with f, it comes to the x3. And gx2. Where is the x2? This is so gx2. And fourth last is x4 is equal to h into x3. So this is a perfect signal flow graph for this for all these equations. So similarly there are few examples are given. So 3 equations are given. If we so first of all first step is we have to consider all the nodes. So here x1, x2, x3 and x4. So 4 nodes we have to consider. Then relation between them is given by all these expressions, and from that we can easily draw signal flow graph. Now some terminologies in a signal flow graph we have to study. So first terminology is input node. So for given diagram, input node is x1 because input node is nothing but source contain only the outgoing branches. So at node x1 only the outgoing branches are present, whereas at node x4 only the incoming branches are present. So we are calling x4 as a output node. A path. So what is path? Path is a continuous unidirectional succession of branches along which no node is passed more than once. So for example, this is one path, x1, x2, x3, x4. This is another path, x1 to x2, x2 to x4. And this is third path, x2 to x3, x3 to x4. Likewise, there are n number of paths. Now, what is a forward path? It is a path from the input node to the output node. So path means it must be continuous unidirectional succession of branches along which no node is passed more than once. But forward path means same path but between input nodes and output nodes, means a path which starts from input node and ends at output node. Then we called it as a forward path. So first forward path is x1 x1 to x2, x2 to x3, x3 to x4, means it starts from x1 ends at x4. Second is x1 to x2, x2 to x4. So these are two forward paths. Then next terminology is feedback path. So here anything is feedback. Feedback means a path, or we can say a loop, which starts from one node, it travels through another node and ends at once again same node. So this is what feedback path. So in this diagram, feedback path is x2 to x3 and once again x3 to x2. So this is feedback path. Next is self loop. So what is the self loop? So this loop is a self loop. It starts from x3, ends at x3 without touching any another node. So self loop is a feedback loop consisting of a single branch, that is A33. Then gain. So the gain of a branch is the transmission function of that branch. So here in self loop gain is a A33. Then between x1 and x2 gain is a A21. So these all are gain. Then what is a path gain? Path gain is nothing but the product of branch gains encounter in the traversing a path. For example, in this forward path, or we can say in a path, gain of a path is A21 into A32 into A43. A21, A32, A43. Then what is a loop gain? So this is one loop. So gain of this loop is A32 into A23. So simple multiplication of branch gains. Then next is all these terminologies we studied. So whether we understand it properly or not, we can check using this example. This is very interesting example. So here signal flow graph is given and we have to find all these parameters. So first parameter is input node. So R of S is the input node, output node is C of S. Then what is a forward path? So how many forward paths are there? So meaning of forward path is a path which starts from input node and ends at output node. So here we can easily get this is one forward path and this is second forward path. We will just check it out. So forward paths are, this is 1, so its gain is g1 of s, g2 of s, g3 of s, g4 of s, g5 of s, g7 of s. And same way this is another forward path. So there are two forward paths. Next is how many loops are there. So first loop is this g2 of s into h1 of s. Second is g4 of s into h2 of s. Then g4, g5, h3 of s. Then g4, g6, h3 of s. So these are loops. Then non-touching loop gain. So here this first loop is non-touching with second loop. We can say first loop is non-touching with third loop. Even first loop is non-touching with fourth loop. So these are combinations of non-touching loops. So simply we are multiplying loop gains of these non-touching loops. So there are three non-touching loop pairs. Next, so this is one more example and this is bit complicated. So please go through it properly. If there are any doubts, please mail me on my email ID. So first, input node we can easily get x1, output node nothing but x8. Then forward path, this is one forward path, this is another forward path, this is third forward path. So I think so there are, see this is one forward path, second, third. So there are three forward paths. Next is loops. So this is very important. It's very complicated circuit. So this is first loop A3 2 A2 3. Second loop A4 3 A3 4. Third, fourth, fifth. Then this is sixth. So these are feedback paths or loops. Some more loops. So it starts from x2 to x4, then x3 to x2. So one more loop, it starts from x5 to x6, x6 to x7, then once again to x5. Now some more loops, please try to understand this. It starts from x2 to x7, then it traverses from x5 to x4 to x3, once again to x2. So this is a complicated loop. It is possible we can miss this kind of loops. One more loop is there. So it starts from x2 to x7, then x6, x5, x4, x3, once again to x2. So self loops are only one self loop, that is x2 to x7 to x7 only. So loop gains. So total how many loops are there? Total 1 2 3 4 5 6 7 8 9 10. So total 10 loops are present in this signal flow graph. So this is a bulky signal flow graph. So it is very difficult task to find all the numbers of loops or loop gains. So it may possible we can miss one loop, and if we miss any loop, trust me class, our answer get changed. This is what path gains. So there are three paths, so three different path gains we get. First is a3 to a4 3 a5 4 x6 5 a7 6. Then second is a7 2, and third is a4 2 a5 4 a6 5 a7 6. So thank you for watching this video. In the next lecture we will start with lecture 8, which is continuation of 7th lecture, signal flow graphs part 2.